Here we are back on the air conditioning of this Honda Fit. And so I now have it in and just put it in. You can actually see it on here. Let's try to get out of reflections. Sorry about this, guys. We'll go over here. I don't think I can get out of reflection. This screen is just so damn shiny. So at this point here, where it says it's 47 degrees, that was when 90-degree air was coming in under fresh air mode. Right there, 47 degrees. Now, at this point where you see it drop off right there and it drops off right there, I put the indoor recycler to recycle air. So that means I'm no longer taking in 90-degree air. It started taking in, this is the cabin temperature. So this temperature right here was inside the cabin, and as soon as I took off the recycle air, it was starting to drop the cabin temperature air. And if you look over right here, you can see it says 80 degrees right there. So it was about 76 degrees when I turned off the recycle. And I'll show you where I'm taking the temperature. So I had to pull the temperature gauge out of here where I showed you in the other video where I take that little panel off, and I took the temperature probe all the way down onto the filter to get the mixed air. And I have it stuck. This is where the air comes out of your vent, it mixes in your car, but the air comes back in here, and the vent for recycle is located up under here. So I stuck the temperature probe to get the true temperature of the air that is actually making it back to the evaporator, because we're watching the cabin temperature come down. So that's the cabin temperature coming down right here, the inside of the car. The inside of the car temperature is roughly, where are we going down to? I really want my Apple back. I do not like the Android. So the interior of the car has come down from what was roughly 80 degrees down to 64 degrees and dropping. The minimum temperature, you can hear the compressor kicking out outside. It looks like it gets down to 40 degrees. And you can hear the compressor kicking out, and we're at 1800 RPMs. So what I'll do is I'll take it out of the 1800 RPMs. And you can see where our superheat's at now. That just the compressor kicked out. Wait for the compressor to kick back in. There, the compressor kicked back in. So for this particular vehicle, when running at 1800 RPMs, at an ambient temperature of 75 degrees under these conditions, the superheat of 20 with a full system at 420 grams, what the factory recommends, the superheat is at this range for this vehicle, not other vehicles, for this particular vehicle under these operations. It changes, and I must stress that. Do not try to play with a rule of averages or rules of thumb or anything like that. So now I'm going to take it off and I'm just going to let it idle. It will no longer set the compressor off because the compressor is now not operating at its most efficient operating speed. And because this is not a great big or very strong variable displacement compressor that can throw its stroke enough to dive the temperature, it won't. And so what we'll see here, it'll represent the blue line is the temperature coming out of the dash. And it has risen because the compressor speed, 44 degrees. And it'll make a slow recovery, and it'll probably, at this ambient temperature, there's no sun load, but it'll probably never go down to 40 degrees like it was here. I'd have to raise the RPMs up on this vehicle. Now remember, some other vehicles, whether you raise the RPMs or not, does not change the pressure at all, and it does not change the cooling. The cooling is decided by the computer what it's going to be. Compressor rotation has nothing to do with it on some compressors. So what I'm telling you here and what I'm showing you here only pertains to this compressor manufacturers with the sensors that they're using to operate this system under these conditions. If I go to that Prius, it'll be much different. If I go to this Infiniti, it'll be totally different. It'll have different superheat, different subcooling. It'll have different pressures, and it'll be totally different. That's an electric compressor. I could rev the engine to 10,000 RPMs and the compressor is not going to see a thing because it's electric, it's isolated. All right, I'm going to get off this one, and they got a Prius here for me, and I'm going to jump over onto the Prius. Actually, they got, if you look around, this is how you can tell when you're at a good shop for Priuses. Prius, they're Fiskars. Prius, Fisker, Fisker. And many Toyotas, another Fisker. This is how you know you're at a good shop, and especially a good shop for Priuses, because they have a lot of experience on Priuses. When you go to a general shop, you want a shop that either specializes in Toyotas, you'll get your best chance of odds of guys knowing your Prius, even if they may not still specialize in hybrids. Because they're a Toyota specialty shop, they're forced to deal with them and they become good at them. Then you have your hybrid shops who just want to do hybrids only. But if you can find a combination of two who are heavy into Toyotas and heavy into Priuses and anything hybrid and coming up electric cars for Toyotas, those are usually your highest chance of getting better service, not getting ripped off to bring your vehicle to. All right, let me jump off of this video. It's been long enough. Oh, let's look at this at idle. Where's it setting at? So take a look at it. This is idle. I no longer have the engine RPMs up. You don't hear the compressor clutch cycling anymore, so you don't hear the engine going up and down. And this is where, this is idle. The compressor does not operate efficiently at idle speed. So here's where our superheat is now. Look at our subcooling. It went all the way down to 2 at idle, but this is not a sufficient range. Here's the temperature of our liquid line, 111, and outside ambient is 75, but it's a little hotter here because we're having roll around of hot air coming around the car and get sucked in over the evaporator. And before I cut out the video, let's take one last look of see where the temperature is going. You can see it's really slowly going down. And let's see what its minimum temperature down. We're down to 42.6 degrees. And our internal cabin air is now down to 60 degrees air, coming back to the lower stat that I have way down there. You see that little bit of yellow right there? So that's one of those temperature and humidity sensors. So the air is all directed out towards, you could see the air moving on the plastic there. I have all the vents facing, so it blows that cold air to the back of the car, and we're starting to get a sun load on here. It's still not all the way inside yet, but it's blowing the cold air back here, mixing. It's absorbing heat off of all the solid material parts in there, the material, the plastic, the glass. And then that air is coming back down low and entering back to the recovery mode, because I do not have it on exterior air, I have it in recycle, and that's the temperature of the air entering back to the evaporator. All right guys, let me get out of here and get on to the next one.